Morning. What I'd like to do in this video is review this system of the heating, ventilation, air conditioning, and the temperatures we're getting on the inside, how the process works, temperatures on the outside, and just a review of the whole system. So I just walked around with, I don't know if you can see the display here, 68. This is down on the lower part, 78. This is on the upper part here where it's insulated, 43, which is surely a reflection in the atmosphere. It's not the surface temperature, but it's because of the foil, it's reflecting a cooler temperature way up in the atmosphere. So this is surface area here down in the lower section, 85, 86, which is, expected in the sun there. The shade maybe a little less, 86. Here the sun is hitting this panel, up about 98. So just briefly here, the top 75, in the shade maybe 70. So we're going to go around here, and in that little shade, 90 still, 89. I don't know if there's a difference that can be seen significantly. 86 on the E panel. I panel, now we're up 104. It's in the sun. It's been in the sun for about an hour, 106. These are the coils, 89. Here, this panel, here, this side, 116. Facing the sun, the white here, down to 104. Up here, unpainted, 114. Down around the side here, again, the lower panel is 89. This is where the compressor is. Usually it's very hot inside. So up here, 91. Over here, the F panel, this is electrical. This is insulated from the other part, 87. Down low, about the consistent 86, a little lower. This panel, 83. This is probably the ambient temperature. And then the top, cool, 71 in the shade, 72. Over here, 82. And then the foil, again, a weird low of 48. And then 78 back in the lower panel down here. So that's the survey of the outside temperatures as they stand now. So let's go inside and see how the air comes back into the house on this side. And now that it's covered, it's hard to see, but there's a duct down there where that comes out of the house. Oh, here it's on. Let's get some measurements. So this is coming out of the house, dropping down 89, 88, 87. We can do the math, the calculus, and compute this where it's going to stop once we have enough data points. So say it's coming out of the house at maybe 78, don't know, 78, there's 78. 77, we're going to get down. We're still dropping about 1/10 of a degree. 76, that's hopeful. It's coming out of the house at that temperature. 73, 76.3. Could it be 75? 75. Well, that's really hopeful. We haven't hit the switch on. It's still, the thermostat room is still set at 77, so the thermostat will still show maybe 76. It's not unusual for the temperature in the rest of the house to be coming in cooler. So we're oscillating 74, 76, 5, 74, 5, 74, 6, 74, 4. Okay, so we can pretty much do the math. Not going to be much below 72 anyways, because it's cooling as we're going. You know, it's cooling the air, and now it's coming back a little bit cooler, so we expect it to be dropping because it's cooling the air, but it is oscillating. So let's go to what it's coming out as. This is the outflow. Hopefully there's no problem in finding the, there it is, right? Where is it? Okay, 64. Kind of hard to see the number, isn't it? 57. It's dropping quickly. 51. 50. 49. 48. Slowing down a little bit. 47. 46, 47. So now it's oscillating, so it's about 46 or 47 degrees Fahrenheit. Right, 46.5. We expect it to continue to drop a little bit because, again, it's cooling the air that's coming in, so it's going to recycle at a little bit cooler temperatures. This was a little cool to the touch, but we saw that in the thermal. Yeah, it is surprisingly cool to the touch. Is it coming through? So a way to check that is to see 45.9. If we can find a point, oh, I can feel the air coming out. This needs a plug of some sort. Because the air pressure is coming out. It's just like a cork or something. All right. Can we reach in here? 66, 67, 68, 69. It's about the 69.7. It's up to 70. This is about that far in where the where there's a junction. You can see it in the other pictures. .74, still going up. So about here. Hard to read. 78.5, 78.8, 78.7, 78.5, 4, 3, 4. Okay, so about 78, right in that little crack. What about the other side? .82, 82. 81, 80, 79, so maybe 75. We can do the math. Probably not much less than that. But that's why these little cracks need to be filled with a foam, so this is not being exposed to the heat isn't getting in through those cracks. The heat transfer is in that direction. And let's feel, yeah, not much. There's probably negative pressure here and positive pressure on the other side. So there's my work table. I wanted to show you, so we're going to pause and then open up the outside there. Just a moment. So we're going to take off this F panel. That's my designation. I just went around and did A, B, C, D, E, F, G. Take some temperatures on the inside. Should be about the same as the incoming temperature, because the lower duct comes in and then it goes through this transfer. Because this is over and under, but the unit is left and right. So the intake air comes in on the side that's closest to us and then goes through the coils, goes back into the house on the far side. So we'll take this panel off and I'll show you the inside. This may not be so easy. We had somebody come out and check the capacitor. We had lost the circulating fan here for the coils last year. He was going to charge us $900 to replace it. I said, no way. So I went down to Carlson's Electric, got a new fan, but with that fan came a capacitor. But the wires aren't that long. And so I wasn't sure about the capacitor because I've never worked with them and I didn't want to mess things up. So we had the repairman hook it up. Well, he didn't put it in where the electrical components are. He put it in where the compressor is. That heat lowers the effectiveness and the length, the life of a compressor. Of a capacitor. So now he put in some more screws down here. I need to change the bit on my drill. Why don't we take a look and show you what I'm talking about. So this is the capacitor side. It's sucking in all this air out here instead of through the coils. These are the coils. This is where the work is done. This squeezes the heat out and then goes through the coils and then releases that heat to blow it out as exhaust. This is the capacitor we had put in, and this is where he put it. It should be inside there. I've got more wire, and I don't know if now's the time to move it in, but there's not much wiggle room in here to get those wires through. So that's what slowed me down. Plus, I don't want to mix it up. They look exactly the same, the two wires. I don't have to yell. All right, so that's the capacitor side. This is where the work is done. That's the workhorse. This is just circulation. Let's see if we can't get those off and show you. So this is where the air circulation is done. Let's just take some initial temperatures. So the floor of this is 68. The coils are 56 and dropping, going back up. The side here is 64. The back end there, 71, 73, which is the air coming in. And there's that transfer. We can see that may be better from the other side. So there is some insulation in here. This panel has a little bit. I wouldn't call it a ½ inch, but I think that's the smallest that's there. It's a fiberglass foil. I want to put some more on the outside. The air conditioning guy never said anything about what I was doing on the top here. I don't know. We can look at this later. It's really not the point of our 88, 84, 86. It's not the point of our study. It's just the airflow. So let's show the other side while it's still off. So this is the side where the air is now cool and it goes back into the house. The blowers are here, and let's see what else we can see. All right, let's get some initial temperatures. 64, 65, 66, 63. Inside here, 61. Over there, 59, 60. Over here, 60, 61. The floor, 83 down there. So you can see this panel has about the same, about half-inch insulation foil. Not sure, boy, that is cool. 68. This is the blower. It takes the air from the coils. I don't know if you can see them back there. Yeah, takes the air through the coils, sucks it in, and then blows it out into this box, which is on the right-hand side, or the side closest to us. And then this takes that air and switches it up to the top. I don't know if you can see. We'll go on the inside, the other side. Maybe we can see a little better. So the air is coming in here in this square, and the air is going back out in that square up to the top. So that's the cold air, and that radiator, by the way, is the old furnace. It's still usable. I still thought there was a way to take energy out of the air by circulating cool water through it, but it isn't very efficient, and there's really no system to accomplish it. The furnace is in the basement, and right now we don't have a circulating pump, and there's other factors in that system where we're not using it now. Questions? You want to see the electronics. These are the electrical controls. This is the power in. This is the thermostat control. This is the schematic. 230 volts. ID fan, whatever that is. Audi fan compressor. Heat pump with electric heat. Power supply. Legend. Fan, the switch. All field wires. Caution, labor wires. Motors are inherently protected. Factory wired for 230. Caution, open all disconnects before surfacing this unit. Serial number. So that's the old capacitor. It's disconnected. I wanted to bring this one into there somehow. This is the schematic for the new one. It's on the cool side because it lasts longer. Oh. This serial number is the unit. The NK7 is September 76 or 77. I mean, doesn't seem right. 2007. Yeah, it was 2007. We can look that up. I have it somewhere. So it was before Mom died. And it was down and dirty. We were getting a discount. They had them cheap. They had really young guys that didn't do the thermostat quite right. And this panel in here, excuse me, I'm going to close this back up. Yeah. This panel in here has some insulation. You can feel it. It's not much. It feels like a little more than this, but it could be just the same. But it still was quite cool to the touch when I experienced it. Just a minute. Knee protection. There's not much light. There's a little more light. So this is the original duct. They came. When it was built, put together, that was what. This is the transfer unit. So there is some insulation here. It doesn't look like it's very well attached, and it's not. so we can see how thick it is. I don't know if they call that an inch or not, but there's the sheet metal on the outside. Seems about the same, looks like it's up to code, but I don't know if we can clean it off and glue it on, but we're putting more on the outside. Let's try that. Let's clean it off and glue it on. Since we're in here, we've got the cleaner. The white is the mastic that they use to seal the gaps. It's quite dirty. When they cleaned the ducts, I asked him if he cleaned the outside of the screen, the other side. He said no, that would be an additional charge. So I don't even know how you could get to it. It go up through the ducts. So this is the return air. Here, a little more clear. It goes up and then into this upper panel and then down. So it goes from over and under to side by side. So we're just trying to stop the, that's a gap. It's like something there, but I don't know if that's the outside or what. We could vacuum that, I suppose. We're trying to keep the heat out. Heat is our enemy at this point. And the way to do that is not just shade, it's insulation. Questions? It doesn't seem very dusty, you know, a little bit. So what I could clean, maybe get the vacuum up here. In case this thing comes on again, we're going to close up this side and the other side so it doesn't just blow hot air back into the house while I'm downstairs getting the vacuum. So I just put this panel back on, I put this screw in, and this did not quite fit. So I used the back of this to hammer that in, and it went in fit. It reminded me of the video I heard this morning, last night, or whenever. Awakening Your Inner W. Edwards Deming. And it's the story about a fellow who worked for Ford, I think, who then went to Xerox. And in the 60s, he was trying to get a handle on quality. And they had a term, snap fit. You put it together and it didn't need a mallet to bang it together to make it fit. And so he began to look at other makes and models of cars. And there was one truck that the whole truck was snap fit. And he says, this is just must be a mistake. So he gave it to his crew, his construction crew, assembly crew. They took it apart and put it all back together, and the whole thing again, snap fit. He brought in one of the executives from corporate and said, listen, this truck, the whole thing is snap fit. And showed him the data and all that, and the executive said, yeah, well, the customers won't know. And that's when he decided to leave Ford. He said, no, I can't work with this. You've got to have a manager that understands statistics and variance and all the rest of that. The system of profound knowledge. So when I was pounding that in, I thought, oh, it's not snap fit. Maybe it's just I don't know, but it wasn't snap fit. So now you know about snap fit. This wasn't either. But again, it wasn't designed for this on the outside. It was just, let's throw it together and let's protect it. So there you have it. I did temporarily close that one, but I didn't seal it on the bottom. So the purpose is to clean this up and then glue it on. And then we're going to put some more panels here, on the other side, and then work on this one. It's already after 7. That's my slow down time. So if I get the vacuum, I think that'll be a good progress. And put that back in. I think that's about all I can do for the day. We've done some nice measurements of temperatures. Little breeze. The sun is hot. I'll give you the sun details, what azimuth and altitude it is. It affects the situation. Maybe I put the piece of foil along here that I didn't finish. But you can see this is the glue, the expansion glue. It's about a 1/2 inch, expands to a 1/2 inch, and it's quite adhesive. This one used a different system. I don't know if you can see in there. It's not the glue, it's the old foam. Here. Hope wind didn't blow it away. I can't find it. So when I put this one on, I had to cut that out. And when I cut it, the measurement, I don't know, was wrong. I measured from one side and then the other side. So I still had about that much. So I took that 2 inches by 4.5 inches and cut the 2 inches to 1 inch, and then the 4.5 inches by 3/4 inch. So I had 5 section there. So 2 times 5 is 10. That is right. I must have had more than that because I ended up with 36. Anyways, this is 1.5 inches. So I cut that in 1/2 inch. I guess I had 6 because that would be 12 times 3 is 36. So that's the 36. Anyways, little squares for spacers. And I used that under here in a grid pattern. So there's one, there's one, there's one, there's one, there's one, there's one. And then glued that, and then glued the foil onto that. I only put them here. I didn't put them over here. So there's that's because there was a strip that was kind of broken and torn. So I put that along that side as a spacer, but it isn't very much. This 1/2 inch is a little better, but again, it's an open gap. So that'll need tape to seal that down. I don't know if we got the temperature underneath it. It's hard to get the temperature on the top. It says 98.7, 97, so that's a fair. 98, that's fair. So what's the temperature inside? It says the same, 98. That's unusual. 97, 96, dropping, 95. Now it's touching the top of the metal. 94, 94, 93. Again, it's hard to see that thing. 93.2, 93.0, 92.9, 92.8, 92.6, 5, 4, 3, 2, 1, 0, 91.9. I think we can do the math and calculate where it would stop, but you get the idea. 91.6 when I pulled it out. So yeah, it's a little warm, but I think it's still on the warm side. I don't know if we can see the cold side. Again, we opened it up, so it's not going to be this one right there. Now there's glue. I glued it pretty good. Oh, there's a gap. Alright, hold. I didn't unhold. I thought I unholded it. 97.1. Really? It's still holding. On, off. 95.7. Let's put it back inside. 95.8, 9, 96.2, 3, 4, 96.4, 5, 6, 96.7, 8. Yeah. 97. the top. 98. Well, that could be. Well, that didn't hold, did it? You can see the glue bead there. It didn't get held, but I put something on top of this. I didn't really tape that down. So maybe that'll be our way to measure this effectiveness. $99 already. 99.9. 99.8. Well, maybe there's hope. Okay, we do have a little power. It's from the inside. There's a crack in the window to, window open a little bit. Hopefully we can seal that. Reverse the outlet on the outside and provide at least half of it to inside and half of it to outside. So, let's see, how do you make it work? Switch. Okay, so that's working. I got some suction. So, excuse me, it kind of. All right, we're gonna vacuum this and then vacuum the inside. Close it down. I don't think we have the time to do much more. It does feel like there was some kind of adhesive, but whatever it wasn't lasting. So again, you can see parts of it were torn off. Let's try the rest of what we have and see if that helps. I want to clean the inside of this, and then there's more probably. So there's some vacuuming around the edges in that crack. I don't know if dusting it down a little bit would help. You can still see some back there. Be careful you don't put your weight on something that can break easily. I did that. I don't know why that doesn't have a lid. I did that on the other one, broke it, had to tape it up to fix it. So this is just a rag. I think it'll help for the dust. Yeah, I can feel a little adhesive. Very little. A roughness to the surface, like spray adhesive or something. So the light isn't turning off. So I'm gonna close out the video and let's see, take it from here. Peace and peaceful journey.